Welcome to the research desk.
Glad to be here. Diving into this?
So, I want you to imagine the fastest land animal on Earth, right? Perfectly optimized for the kill, but collapsing from just a simple common virus.
A total systemic failure from a minor shock.
Exactly. Now, take that image and imagine the global financial market. It's perfectly optimized to trade in microseconds, right? But then it collapses by 1,000 points in a matter of minutes.
Right. The 2010 flash crash.
Yeah. And on the surface, a cheetah and a high-frequency trading algorithm, well, they share absolutely nothing. I mean, we are dealing with entirely different substrates here.
Radically different.
Right. On one side, we have the 3.8 billion year history of biological evolution, operating through, amino acids, nucleotide base pairs, chromosomes, and on the other side,
The modern microstructure of global finance.
Exactly. Clearinghouses, fiber optic cables, limit orders. Yet, what if I told you that the exact same mathematical equation dictates the survival and the catastrophic failure of both systems?
That is a bold claim.
It is, that the math is undeniable. That equation is Shannon entropy. It was developed by Claude Shannon back in 1948 at Bell Labs, originally to quantify information in telecommunications.
Right, the foundational text of information theory.
Precisely. And the equation itself is H equals the negative sum of the probability of X multiplied by the base 2 logarithm of the probability of X.
Okay, but before we go any further, we really must translate that equation into a physical reality.
Absolutely.
Because honestly, the mathematics alone will obscure the mechanics we need to examine today. When we talk about the probability of X in Shannon entropy, we are fundamentally talking about the distribution of variety within a defined space.
Variety being the key word there.
Right. Think of simple alphabet blocks resting on a table. If you have 100 blocks and, well, every single one of them is the letter A, your variety is 0.
because you know exactly what you're going to pick.
Exactly. The probability of picking an A is 100%. So in Shannon's mathematics, the entropy of that system is 0. It is perfectly uniform, it's highly concentrated, and it's completely predictable.
A state of total order.
Yes. Conversely, if you have 26 different letters distributed evenly across those 100 blocks, the probability flattens out, right? The entropy is high.
Because the system contains vast diversity and disorder.
Precisely.
And my core position today is that biological evolution is fundamentally an entropy engine governed by that exact dynamic.
I'm tracking with you.
In biology, the blocks are genetic variants, known as alleles. So high genetic entropy means a population possesses a massive library of different physical traits, metabolic pathways, immune responses, all of it.
A wide distribution of biological possibilities.
Right. And evolution requires two opposing forces to actually function. First, mutation. Mutation is the ultimate entropy injector.
It throws new letters into the pile of blocks.
Exactly. It acts as an organic randomizer. It introduces new genetic variations, flattening the probability distribution and ensuring that biological alphabet remains diverse.
But mutation alone is just chaos, right? It's just random noise.
Exactly. Which is why it requires a counterforce. And that counterforce is natural selection. Natural selection acts as the supreme entropy compressor.
It removes the failed letters.
Yes, it tests these genetic hypotheses against the environment, and it relentlessly eliminates the failed variants. It takes a high entropy state of thousands of possible biological designs and sharpens the distribution.
Compressing the genetic code around the singular successful variant.
You've got it. This tension between entropy injection and entropy compression, it's not a mere side effect of life on Earth. It is the explicit mechanical engine of all biological adaptation and survival.
I approach this dynamic from a radically different domain, focusing on how we have constructed our global financial ecosystems.
The limit order books?
Yes. And while I entirely agree that the mathematical isomorphism between biology and markets is flawless, the practical reality of how we have engineered our financial exchanges over the last 20 years, well, it should terrify anyone paying attention.
Terrify is a strong word.
But accurate. Let us translate the biological alleles into market microstructure. The fundamental unit of modern price discovery is the limit order book.
The digital shelving system.
Exactly. Visualize a massive shelf. On the left side, you have the bids. These are buyers publicly stating the price they are willing to pay and the exact number of shares they want.
And on the right side, the asks.
Right. Sellers stating the price they demand. So when a new limit order arrives at a price level far away from the current trading price, it acts exactly like your biological mutation.
It injects entropy into the order book.
Yes, it spreads the available liquidity across multiple different prices. This creates a flat, high-entropy probability distribution of potential trades.
And just as natural selection compresses genetic entropy, the actual act of trading compresses market entropy.
Exactly. Executed trades as well as canceled orders, they act as the selection mechanism. They remove liquidity from the book, compressing the entropy.
Which makes the market more efficient.
On paper, yes. But here's the critical vulnerability. Over the past 2 decades, we have entirely outsourced the role of the natural selector.
You're talking about high-frequency trading.
I am. We have handed the survival of our financial ecosystem over to a microscopic, highly optimized oligopoly of high-frequency trading firms.
Firms like Citadel, Virtua, Jane Street.
Right. And jump trading. Those few firms now intermediate more than 50% of all U.S. equity volume. They are ruthlessly, mechanically compressing order book entropy in real time.
Operating in fractions of a millisecond.
Yes, by relentlessly quoting at the very tightest prices and instantly canceling orders when conditions change, they have driven the entropy of our markets to an artificial near-zero state.
But that near-zero state has massive benefits.
I will demonstrate today that while this low entropy state appears spectacularly efficient, it has rendered the underlying architecture of global finance inherently catastrophically fragile.
Okay, well, we need to examine what that compression actually achieves before we just condemn it as fragile.
I'm listening.
We must look at the sheer, unparalleled performance that extreme entropy compression unlocks when a system finds its ultimate optimization.
Back to your cheetah, I assume.
Back to the cheetah, Oceanonyx jubatus. The cheetah represents evolution's most extreme surviving example of low genetic entropy in a complex mammalian predator.
Because of a population bottleneck, right?
Exactly. To understand why it's so optimized, we have to look at the mechanics of that bottleneck. Roughly 10 to 12,000 years ago, during the late Pleistocene epoch, a massive extinction event hit.
Wiping out a huge percentage of large mammals.
Roughly 75%, yes. The global cheetah population plummeted, perhaps down to a few hundred or even fewer localized individuals living in a highly restricted geographic range.
So inbreeding became biologically mandatory for the survival of the species.
A forced extreme selection event, an absolute purging of genetic variants.
They lost all their entropy.
Almost all of it. The biological diversity that survived that bottleneck was so incredibly narrow that, functionally speaking, modern cheetahs are essentially genetic clones of one another.
How do we quantify that mathematically, though?
We look at the major histocompatibility complex, or the MHC.
The immune system genes.
Right. The MHC is the dense cluster of genes responsible for the immune system's ability to recognize foreign invaders. In humans, the MHC is wildly diverse.
Which is why finding a compatible organ donor is so phenomenally difficult.
Exactly. Your body recognizes the high genetic entropy of another human and it attacks the foreign tissue. But in cheetahs, the MHC diversity is functionally zero.
Zero? Really?
Yes. You can perform complex skin grafts between two entirely unrelated cheetahs born on opposite sides of the African continent, and their immune systems will not mount a rejection response.
That is incredible. They really are a biological monoculture.
They are. The probability distribution of their alleles is entirely compressed around a single genotype. But, and this is my point, observe the mechanical result of that monoculture.
Raw speed.
Yes. This relentless selection, the discarding of billions of failed genetic experiments over millennia, produced the fastest land animal on the planet.
It is flawlessly adapted to its specific ecological niche.
Flawlessly. Its anatomy is a marvel of singular optimization. It possesses a uniquely flexible spine that functions like a coiled spring, and semi-non-retractable claws that act as permanent running cleats for traction.
And the massive nasal passages for oxygen intake during a sprint.
Exactly. Selection works. When you compress entropy, you eliminate the metabolic drag of unnecessary variation. You amplify the singular mechanical design that achieves ultimate performance.
Well, the biomechanics of the cheetah are undeniable. I'll give you that. Thank you.
But we must examine the hidden systemic cost of that performance. Let us map the cheetah's anatomical optimization perfectly onto modern price discovery.
Okay, let's make the jump.
I will concede the raw performance metric. When a limit order book concentrates all of its liquidity at the absolute best bid and the best offer, when the spread between the buyer and the seller is microscopic, the order book entropy is incredibly low.
And the result is a marvel of financial efficiency.
Yes, high-frequency trading algorithms are performing the exact same function as that Pleistocene evolutionary bottleneck. They are acting as relentless, hyper-efficient natural selectors,
Continuously posting quotes across thousands of equities.
identifying and arbitraging MyNet pricing discrepancies in microseconds. Yes, they compress the entire vastness of the order book around the mathematically correct price.
And the end user reaps the benefit of that precision?
The data certainly reflects a dramatic reduction in friction. I won't argue that. Consider the mechanics of trading today versus 30 years ago.
The 1990s floor traders.
Exactly. Today, a retail investor can open an application on their phone and purchase 100 shares of Apple with a bid-ask spread of a single penny.
1 cent separates the buyer and the seller.
Yes, and to understand how low entropy that is, we must look at the high entropy environment of 1990. Back then, the limit order book was not managed by algorithms.
It was managed by human specialists, physically standing on the floor of the New York Stock Exchange.
Shouting at each other. Trading was done in fractions, specifically eighths of a dollar.
So the absolute minimum spread you could encounter was 12.5 cents.
Right. Furthermore, placing that order involved a human broker, manual entry, and a commission that often exceeded $50 per single trade.
The market was slow, the liquidity was spread out, and the entropy was vastly higher.
Which meant a ton of drag. The HFT selectors have optimized the market's phenotype to a point where transaction costs approaches zero. Capital allocation is mathematically frictionless today.
Okay, well, if transaction costs approach zero and capital allocation is perfectly frictionless, why shouldn't we celebrate that optimization?
Because of what you sacrifice to get it.
You are treating the elimination of drag as a systemic danger, rather than the logical endpoint of a system finding its most perfect state.
It is a danger.
But if biological variation or market liquidity at distant price levels only serves to introduce inefficiency, why shouldn't the engine eliminate it?
Because optimization and extreme fragility are inherently permanently linked.
Explain that.
Let us bring the focus back to the immune system of your cheetah. Yes, its spine and claws make it the fastest predator alive, but it is simultaneously one of the most endangered mammals on Earth.
Due to habitat loss, mostly.
And due to the fact that it is fatally vulnerable to exogenous shocks, precisely because of the genetic compression you are praising.
You're referring to the FIP outbreak?
I am. In the 1980s, an outbreak of feline infectious peritonitis, or FIP, swept through a captive breeding population of cheetahs in Oregon.
It's caused by a feline coronavirus, right?
Yes. Now, in domestic house cats, which possess normal, healthy genetic diversity and a high Shannon entropy in their MHC genes, this specific virus has a mortality rate of less than 5%.
Because the diverse immune system acts as a multifaceted lock and key defense.
Exactly. If one genetic lock fails to recognize the virus, another cat in the population possesses a lock that succeeds. The population as a whole survives.
But the cheetahs lack the variants to mount a novel defense.
Exactly. In the cheetah population, the exact same strain of FIP virus killed 60% of the infected animals.
Wow. That's a massive jump in mortality.
The mortality rate was an order of magnitude higher. They had absolutely no biological variation to fall back on. Their immune systems were perfectly optimized for the pathogens of the past, but they were biologically blind to the novel shock of the present.
The virus exploited the single, uniform vulnerability present in every single cat.
And that exact same fatal flaw exists in our penny-spread, high-frequency equity markets.
You think the markets are biologically blind to shocks?
I do. The cheetah sprint speed and the market's penny spreads share a single structural foundation: low entropy. The tight spreads mean maximum efficiency during normal conditions, but they also mean the order book is a monoculture.
So if conditions change,
If the macroeconomic environment changes even slightly, if a shock arrives, there is no diverse order flow sitting further back in the book to absorb the impact.
right, I understand the vulnerability you are pointing out. However, the cheetah susceptibility to a novel virus is a consequence of a static environment suddenly becoming volatile.
Markets are inherently volatile.
But evolution never promises absolute permanence, right? It only promises localized adaptation to the current environment.
Fair enough.
And it is true, when we examine the deep historical record, massive shifts in environmental conditions ruthlessly expose the vulnerabilities of highly compressed, low-entropy systems.
They shatter them.
Yes, and this leads us directly to the mechanics of systemic collapse. When a low-entropy system faces an exogenous shock, the failure is not localized, it triggers mass extinction.
The ultimate systemic failure.
Exactly. To understand this structurally, we must examine the Permian-Triassic extinction event, which occurred roughly 252 million years ago.
The boundary between the Paleozoic and Mesozoic eras?
Yes, the Great Dying. This represents the ultimate example of a catastrophic entropy collapse in the biological domain. Let's look at the mechanics of the biosphere prior to this event.
What was the baseline entropy?
Global marine ecosystems had achieved extreme stability. They had reached a state of profoundly low ecosystem entropy, completely dominated by highly specialized, heavily armored organisms.
Give me an example.
You had trilobites, which possessed incredibly intricate calcium carbonate exoskeletons perfectly adapted to scavenging the seafloor. You had rugose corals building massive reef structures and fusulinid foraminifera dominating the microecosystem.
All highly specialized.
Incredibly so. These dominant species had locked in their ecological positions for tens of millions of years. Systemic entropy was falling steadily as these absolute specialists outcompeted all generalist life forms.
They were the HFT firms of the Permian Ocean.
That's a great way to put it. Ruthlessly efficient, totally dominant.
And completely reliant on the ocean chemistry remaining perfectly stable.
Precisely. Then, the exogenous shock arrived.
The Siberian traps.
Yes. And this was not a standard volcanic eruption. It was a massive flood basalt event. Deep fissures opened in the Earth's crust, eventually covering an area of 2 million square kilometers in molten rock.
Unimaginable scale.
And the magma intruded into massive underground coal basins, essentially incinerating fossil fuels on a planetary scale.
Injecting staggering, unprecedented quantities of carbon dioxide and methane directly into the atmosphere.
The mechanical consequences were devastating. Global temperatures spiked by 5 to 8 degrees Celsius. The oceans absorbed the carbon dioxide, leading to severe ocean acidification and widespread marine anoxia.
The total depletion of dissolved oxygen in the water.
Exactly.
And the exoskeletons of those specialists began to physically dissolve in the acidic water.
Yes. The dominant marine species were exquisitely, narrowly adapted to the alkaline, oxygen-rich waters of the pre-extinction world. Their genetic entropy was deeply compressed.
They had no alternative metabolic pathways.
None. They possessed no biological variants, no way to handle a sudden 5-degree temperature shift or highly acidic water. The trilobites, the rugose corals, they were annihilated.
96% of all marine species were wiped out, if I remember correctly.
96%. And 70% of all terrestrial vertebrate species followed. The specialized, low-entropy dominant species collapsed entirely.
So who survived?
The generalists. Organisms like the Lystrosaurus, a medium-sized, highly adaptable herbivore with broad environmental tolerances, high genetic diversity, and the ability to burrow and eat varied diets.
The organisms with high internal entropy survived the environmental shock.
Exactly. The lower entropy organisms were functionally liquidated. But, and this is crucial, I argue that this mass extinction is not a flaw in the evolutionary engine.
You think wiping out 96% of life is a feature?
I think it is the necessary mechanical clearing process that allows a stagnant system to reset.
A clearing process in geological time might look like a necessary reset,
But when you transition the time frame from tens of millions of years to a handful of milliseconds,
The math stays the same.
the math stays the same. But the violence of that clearing mechanism becomes a systemic terror that we simply cannot afford to tolerate in human systems.
You're bringing this to the flash crash.
Let us map the mechanics of your Permian-Triassic extinction directly onto the events of May 6, 2010, the flash crash. The minute-by-minute timeline of this financial event is the exact biological collapse you just detailed, running at hyperspeed.
The environment was already stressed that day, right?
Yes, the environment leading up to that afternoon was tense due to macroeconomic news out of Europe regarding the Greek debt crisis, but the market was functioning normally.
Until 2:32 p.m.
Then, at 2:32 p.m. Eastern Time, the financial equivalent of the Siberian traps erupted.
The Waddell and Reed algorithm.
Correct. A large mutual fund complex, Waddell and Reed, initiated an automated execution algorithm to sell 75,000 E-mini S&P 500 futures contracts.
That is a massive order.
Roughly a $4.1 billion position, but the fatal mechanical flaw was that the algorithm was programmed to execute the sale based solely on market volume.
Completely ignoring price and time parameters.
Exactly. It was a blunt instrument striking the highly optimized low-entropy limit order book. Within minutes, the algorithmic ecosystem of the market began to physically choke on the volume.
And how did the dominant HFT firms react?
The 3 or 4 dominant HFT firms, the trilobites, and the rugose corals of our market ecosystem were engaging in a practice known as hot potato trading.
Right, trying to shed risk.
Yes, they were rapidly buying and selling the same contracts back and forth to each other in milliseconds, attempting to shed the toxic risk generated by the mutual fund's massive sell order.
Which inadvertently generated enormous trading volume.
Exactly. And that volume trickled back to the Waddell and Reed algorithm, which was pegged to volume, causing it to sell even faster.
A disastrous positive feedback loop.
And then, the HFT firm's internal risk models triggered. They realized the environmental conditions of the market had become fundamentally toxic.
The financial ocean became acidic.
Perfect analogy. And their mathematical response was immediate and binary. They simultaneously withdrew their liquidity. They canceled their resting limit orders.
Just pulling the plug.
We have the precise data on this collapse, too. Prior to 2:32 p.m., the order book's Shannon entropy showed a healthy, normal distribution of liquidity across multiple price levels. It was sitting around an entropy score of 3.2, which is quite robust. But when the HFTs withdrew, that score instantly collapsed to 0.4.
A massive, near-total compression of market diversity.
It was a mass extinction of liquidity occurring in the space of 3 minutes. With the specialized market makers gone, the order book hollowed out completely.
Because the specialist died?
The Dow Jones Industrial Average plummeted 998.5 points. Nearly 10% of the entire market's capitalization evaporated.
Because there was no resting diversity to catch the fall.
Right. Because the order book entropy was entirely gone, there were no resting orders to catch the falling prices. Market orders placed by retail investors simply fell through the empty space of the order book until they executed against absolute anomaly prices resting at the very bottom.
The stub quotes.
We call them stub quotes. Exactly. They're placeholder orders placed by market makers at extreme prices just to fulfill regulatory requirements. They were never meant to be executed.
But they were.
As a result, massive blue-chip corporations traded at entirely irrational values. Accenture, a global consulting firm, traded at 1 single penny per share.
That is unbelievable.
Sotheby's briefly printed at $99,999.99 per share. The 2010 flash crash was the Permian-Triassic extinction compressed into 20 minutes. A low diversity of liquidity providers made the underlying structure of the market fundamentally fragile to a single, localized shock.
I mean, the parallel is structurally flawless, I have to admit. The Shannon entropy dropped in a mathematically identical fashion in both the ocean and the exchange.
Exactly.
But I would argue that, just as the Permian-Triassic extinction was necessary to clear the ecological board, ultimately paving the way for the adaptive radiation of the dinosaurs and subsequently mammals, these market clearouts expose the dangerous weaknesses in the current optimization.
You think it makes the market stronger?
They force the system to adapt.
Well, that assumes we actually allow the market to adapt and organically diversify after these shocks. But the data shows the complete opposite. We are using these crises to drive the systemic entropy even lower.
How so?
To understand how dangerous this trajectory is, we must analyze the Knight Capital incident of August 1st, 2012.
The $440 million glitch.
It was more than a glitch. This event was the financial equivalent of a catastrophic biological bottleneck that permanently reduced the diversity of the survivor pool.
Knight Capital was huge at the time.
They were one of the largest market makers in U.S. equities, responsible for routing roughly 10% of all retail trading volume. During the weekend prior to August 1st, Knight deployed a new software architecture.
SAMRs? The Smart Market Access Routing System?
Yes, but the deployment was mechanically flawed.
It was a procedural error, right? Not a coding error initially?
It was a catastrophic procedural error. The technicians updated the software on 7 of the firm's 8 servers. They forgot the 8th server.
Ouch.
Because of this oversight, an obsolete dead piece of trading code known as PowerPeg was accidentally reactivated on that 8th server.
And what did PowerPeg do?
PowerPeg was designed years earlier to test the market by intentionally buying high and selling low.
A function purely for internal quality assurance.
Yes, it was never meant to interact with live capital. It was the exact biological equivalent of a dormant lethal retrovirus waking up within a genome.
Wow.
At 9:30 a.m., when the market opened, the retrovirus activated. The SMR system began routing thousands of orders to the 8th server, which obediently executed the PowerPeg logic.
Or began aggressively taking losses at the speed of light.
Minute by minute, the code sent millions of unintended orders into the live market. It systematically bought shares at the offer price and instantly sold them at the bid.
Locking in tiny microscopic losses thousands of times a second.
In just 45 minutes, Knight Capital executed 4 million trades. They accumulated a staggering $7 billion position in unwanted equities and realized a permanent cash loss of $440 million.
Which wiped them out.
That massive sum was greater than the firm's entire market capitalization. By the time the technicians physically severed the connection, the firm was mortally wounded. Within months, one of the primary pillars of liquidity in the U.S. stock market was functionally extinct.
And the consequence of that extinction was inevitably further consolidation of the ecosystem.
Exactly. The death of Knight Capital permanently removed a massive source of order book diversity. The entire market's baseline ecosystem entropy dropped.
And Virtu bought them, right?
Ultimately, Virtu Financial, an even larger HFT competitor, acquired the remains of Knight Capital. What did this shock accomplish?
It concentrated the market further.
It certainly did not reset the system to a higher entropy, healthier state. It forced further consolidation. It left us with even fewer dominant players, relentlessly lowering the financial ecosystem's baseline entropy.
Setting the stage for an even more correlated collapse down the line.
Precisely. Every extinction event in modern market microstructure systematically reduces the diversity of the surviving participants.
Okay, I acknowledge the severity of the consolidation, and the Knight Capital event is a stark example. However, I fundamentally disagree that the market, or any complex adaptive system, is permanently trapped in a downward terminal spiral of entropy compression.
How does it escape then?
We must examine how systems actually survive, rebuild, and innovate over time. Because if the mathematical tension between variation and selection is real, there must exist a physical mechanism for massive entropy injection.
Without causing an extinction.
Exactly. And in biology, we don't have to rely on the fossil record for this. We have observed this mechanism operating in real time under rigorous control.
The LTE?
Yes, I want to dive deeply into the mechanics of Richard Lenski's E. coli long-term evolution experiment, universally known as the LTE.
Started in the late 80s, right?
Dr. Lenski launched this experiment at Michigan State University in February of 1988. It stands as one of the most elegant, irrefutable demonstrations of the entropy engine ever constructed.
Let's walk through the exact physical parameters of the experiment for clarity.
Lenski took a single ancestral strain of Escherichia coli. He distributed this bacteria into 12 separate glass flasks containing a precisely controlled liquid growth medium.
Setting the baseline.
Crucially, he started the experiment at absolute zero genetic entropy across all 12 populations. They were perfect clones of each other. The environment in the flasks was highly restrictive. The bacteria were provided with a small amount of glucose, which they would exhaust every single day.
A starvation cycle.
Right. The mechanical routine was rigid.
Every 24 hours, 1% of the surviving bacteria from each flask was pipetted into a brand new flask with fresh glucose.
Creating a severe, constant evolutionary pressure to optimize glucose metabolism.
Exactly. Today, this process has continued uninterrupted for over 75,000 generations. Furthermore, Linsky periodically freezes samples of the bacteria, creating a living fossil record that can be thawed and directly compared to current generations.
And mathematically, what does the flow of Shannon entropy look like inside those 12 flasks over the decades?
Well, it manifests as a continuous rhythmic cycle of entropy injection and extreme compression.
Walk me through a cycle.
As the bacteria divide, transcription errors occur in the DNA duplication process. These random mutations represent an injection of genetic entropy. Suddenly, the genetic diversity inside a flask increases slightly. The probability distribution of variance flattens out.
The biological alphabet expands.
Exactly. However, the environment is relentlessly selecting for the fastest glucose metabolizers. So when a beneficial mutation arises that allows a bacterium to process glucose marginally faster, that specific variant rapidly outcompetes its peers.
It dominates the flask.
It sweeps through the entire population in a matter of days. As it achieves total dominance, the genetic entropy of the flask crashes back down to near zero.
The system compresses again.
Injection, compression, mutation, selection. The cycle repeats thousands of times.
But for decades, this was merely extreme optimization for a single task, eating glucose faster. It was the cheetah optimizing its sprint. It wasn't fundamentally new.
Exactly. Until a profoundly revolutionary moment occurred.
Generation 31,500.
Yes. Around generation 31,500, in one specific flask, designated ARA3, the fluid suddenly turned incredibly cloudy. The bacteria population had exploded to anomalous levels.
What happened?
When Linsky's team analyzed the genome, they discovered something astonishing. A complex series of mutations had arisen that allowed the E. coli to metabolize citrate in the presence of oxygen.
Citrate.
Yes. The growth medium had always contained abundant citrate as a stabilizing agent, but E. coli, by biological definition, lacks the ability to consume citrate in aerobic conditions.
That inability is a defining characteristic of the species.
It has been for millions of years.
So this was a fundamental shift in the organism's capabilities.
It wasn't just a minor optimization of an existing trait. It was an entirely new metabolic phenotype. It is the biological equivalent of an entirely new, highly lucrative asset class appearing out of nowhere on a financial exchange.
Like crypto appearing in the 2010s.
Perfect analogy. And through genomic sequencing, Linsky proved that this was not a single lucky mutation. It was the result of historical contingency.
Meaning what exactly?
Several earlier, seemingly neutral mutations had silently accumulated in the population, tiny injections of uncompressed entropy. These early mutations laid the necessary architectural groundwork.
So without those specific prior variations, the final mutation that unlocked citrate metabolism would have been impossible.
Precisely. The LTE proves mechanically that continuous microscopic entropy injections, even within a highly controlled low-entropy system facing relentless selection pressure, will eventually compound into revolutionary systemic leaps in capability.
The mathematical elegance of the LTE is profound, I admit that, but we must address the scale and the time frame.
What do you mean?
It required 31,500 generations. Decades of human time in a perfectly stable, hermetically sealed laboratory environment to achieve that single phenotypic leap.
True, but bacteria reproduce quickly.
But when we analyze the survival of global financial markets or macro ecosystems, we do not have the luxury of perfectly controlled isolated flasks. We require massive, uncontrolled, systemic injections of entropy to rebuild resilience after a shock.
Okay, then let us scale the concept up to the largest, most spectacular natural example of entropy injection in the history of the planet.
The Cambrian Explosion.
The Cambrian Explosion. We are looking at a time frame roughly 541 to 515 million years ago. If the LTE is a slow drip of mutation, The Cambrian Explosion is nature's ultimate quantitative easing program.
A massive flood of diversity.
Let us examine the mechanics of the biosphere prior to this period, known as the Ediacaran. Life on Earth was overwhelmingly microbial, or consisted of very simple, soft-bodied, immobile organisms.
Resembling ferns or quilted mattresses, mostly.
Right. Ecosystem entropy was vanishingly low. There was a profoundly narrow distribution of body plans, very limited ecological niches, and essentially zero complex predator-prey dynamics.
The biological alphabet had barely a few letters.
And then, the biological order book flooded.
Flooded is an understatement.
Biological instant, just 25 million years, representing roughly 0.5% of Earth's total history. The evolutionary mutation machine injected an unprecedented volume of structural entropy into the oceans.
Driven by the Hox genes, right?
Yes, the underlying genetics of life, specifically the Hox genes, which dictate fundamental body architecture, diversified rapidly. Every major animal phylum that exists today appeared almost simultaneously in the fossil record.
So everything from insects to vertebrates.
We see the emergence of arthropods with jointed limbs, mollusks with complex shells, echinoderms, annelids, and chordates, our own distant ancestors possessing the first primitive spinal cords.
It's a total structural revolution.
We look at fossil sites like the Burgess Shale in Canada, and we see apex predators like Anomalocaris, a meter-long organism with compound eyes and grasping appendages, swimming alongside armored, spiky prey.
A total flattening of the probability distribution.
Exactly. Mathematically, the Shannon Diversity Index of marine body plans leaped from an H value of roughly 1.0 to an H of nearly 3.5.
A massive spike in entropy.
The biosphere transitioned from testing a handful of conservative designs to testing an astronomical number of radical biological hypotheses simultaneously. The ecological distribution was completely flattened out.
The state of maximum biological disorder.
But it was also the state of maximum creativity and resilience. The Cambrian Explosion is the perfect planetary-scale illustration of why vast, uncompressed variation is the absolute prerequisite for both systemic resilience and macro-level innovation.
It is a stunning biological narrative, I won't deny that, but I must push back aggressively on how we apply this Cambrian Explosion framework to the architecture of financial markets.
Where does the framework fail?
The critical mechanical question is this. Can a financial market organically inject that level of structural entropy without suffering a catastrophic fracture first?
You're saying the injection requires trauma in finance?
In biology, the Cambrian Explosion appears as a pure, creative, adaptive radiation. But in market microstructure, that high-entropy state of maximum disorder only ever seems to materialize in the immediate, violent aftermath of a systemic crash.
Wow.
Let us return to the exact mechanics of May 2010. The market did not smoothly, peacefully transition into a high-entropy, diverse state of order flow. It fractured violently.
The HFTs withdrew.
The highly optimized HFT algorithms pulled their liquidity, and the bottom fell out of the price discovery mechanism.
But the system did recover. Diverse order flow eventually re-entered the market.
It did recover, but we must examine how it recovered. It was only after the crash hit the absolute bottom that we witnessed a massive, sudden injection of high-entropy order flow.
When the specialized algorithms fled.
Yes, when they fled, the resting limit orders sitting deep in the book, orders placed hours, days, or weeks earlier by retail investors, mutual funds, and slow-moving institutions far away from the active trading price, they became the vital nucleus of the market's recovery.
These were the generalists.
Exactly. The market suddenly flooded with a diverse, chaotic mix of panicked liquidations and highly opportunistic buying. It was a Cambrian explosion of completely uncoordinated, heterogeneous trading strategies.
And that chaotic high-entropy flow successfully rebuilt the fundamental price discovery mechanism. The market found its footing.
It did, but the systemic danger is that our current market architecture absolutely requires trauma to achieve that necessary diversity.
Unlike biology.
Right. Biological systems have engineered an organic mechanism to inject entropy continuously. That mechanism is sexual reproduction. Sexual reproduction is nature's dedicated, systemic diversification strategy.
It organically injects genetic entropy into every single generation through the mechanical process of genetic recombination, literally shuffling the DNA sequences of two parents to ensure the offspring are genetically distinct.
It constantly broadens the probability distribution of alleles.
Yes, it maintains a robust baseline of systemic resilience without requiring a localized mass extinction to reset the genome.
So you are suggesting that diverse order flow serves the exact same systemic function as genetic recombination.
Exactly. A diverse order flow, a market composed of pension funds holding for decades, retail traders holding for weeks, and algorithmic market makers holding for milliseconds, is the financial equivalent of sexual reproduction.
It keeps the gene pool healthy.
It constantly shuffles the structural genes of the market to prevent the onset of a fragile monoculture. But look at the mechanics of our current ecosystem. We are dominated by a handful of high-frequency trading firms executing highly predictable, tightly correlated deterministic algorithms.
The clones.
Right. A financial market dominated by 3 HFT firms running nearly identical latency arbitrage strategies is not engaging in sexual reproduction. It is simply cloning itself millions of times a second.
And that severely lowers the resilience.
That severe entropy compression means we are structurally reliant on the violence of the next flash crash to forcibly inject the entropy we desperately need to survive.
I see the structural vulnerability you are identifying, but to truly understand how these macro-level systemic failures are triggered by micro-level dynamics, we have to look beyond the raw aggregate measurement of Shannon entropy.
What else is there to measure?
We must examine the precise mechanics of how information flows through the distinct layers of a complex system. To do this, I want to introduce a highly specific mathematical concept: transfer entropy.
Formulated by Thomas Schreiber, right?
Exactly. In 2000, transfer entropy measures the directed causal flow of information between two coupled variables. It quantifies how the history of one specific component predicts the future behavior of another distinct component.
The butterfly effect, mathematically formalized.
Yes, it is the mathematical mechanism of how microperturbations cascade into macro collapses.
Let's ground that abstract definition in the biological reality of the entropy engine.
Sure, in biology, transfer entropy flows bidirectionally between the micro level of genetics and the macro level of ecology.
Give me an example.
Consider the mechanics. A single random nucleotide mutation occurs at the microscopic genetic level, perhaps altering the shape of a single protein in a beaver's tooth.
Okay, a micro-level change.
That microscopic event cascades upward, altering the beaver's macroscopic phenotype, allowing it to fell larger trees. That phenotypic change alters how the beaver interacts with its local ecology, leading to the construction of larger dams that fundamentally change the flow of a river system.
So the microgene changes the macro ecosystem.
Exactly. The altered river changes the survival parameters for the entire regional ecosystem. That ecological shift then feeds back downward, exerting entirely new selection pressures on the beaver population, determining which specific genetic mutations will survive the next generational cycle.
So it's a loop.
Genes flow to organism, organism flows to ecosystem. Ecosystem dictates selection, selection compresses the genes. We can rigorously, mathematically measure this causal information flow.
And when we translate that exact bidirectional flow into market microstructure, we see that transfer entropy flowing violently between the micro level of individual order flow and the macro level of the overarching market regime.
This is the cascade you're worried about.
This is the precise mechanical anatomy of a flash crash. Imagine the limit order book. A single large block order, one isolated trade from an institutional investor, arrives at the exchange matching engine.
Like the Waddell and Reed order.
Exactly. That microscopic event cascades upward, immediately depleting liquidity at multiple price levels and physically altering the shape of the limit order book.
And the algorithms see that change.
That new order book topography instantly alters the calculated risk parameters of the high-frequency market makers who are monitoring the feed.
And their algorithmic reaction triggers the macro-level cascade.
Exactly. Their automated reaction, usually a rapid withdrawal of their own limit orders, changes the overall liquidity available to every single participant in the market.
The ecosystem changes.
And executed. The May 2010 flash crash was not just a drop in prices, it was fundamentally a massive transfer entropy event.
Information flowing wildly across layers.
Yes, information flowed from the micro-order level to the macro price level, fed back on itself instantaneously, and amplified a routine, albeit large, structural perturbation into a total systemic seizure. The Waddell and Reed order was the mutated gene that altered the ecosystem.
Precisely. And understanding transfer entropy provides us with a powerful predictive diagnostic tool.
How so?
When transfer entropy is elevated, when we can measure that small, routine perturbations at the microscopic level are reliably and violently cascading into macroscopic consequences, the system is mathematically proven to be highly fragile.
It's on the edge of a cliff.
It has entered what we classify as phase 2, the fracture phase. If researchers look at the granular tick data leading up to the 2.32 p.m. crash in 2010, they observe a significant measurable spike in the transfer entropy between individual order flow and aggregate price movement.
Before the crash actually happened?
Yes, small, entirely routine trades were beginning to exert wildly disproportionate impacts on the macro price of the S&P 500.
It was a mathematical warning siren. It was the definitive signal that the order book's structural immune system was failing. The superficially tight spreads and high transaction speeds completely masked the underlying mathematical reality that the ecosystem had lost its capacity to absorb localized shocks.
Efficiency, masking, fragility.
Exactly. The spike in transfer entropy was the physical fever preceding the grand mal seizure of the market.
And that bidirectional cascade is exactly why I argue the current HFT monoculture is so existentially dangerous.
Because it amplifies the cascade?
It engineers an environment where transfer entropy can spike exponentially without warning, because the ecosystem lacks any structural friction. There are no diverse, generalist limit orders resting in the book to act as shock absorbers and break the cascade.
Because the HFTs are all clones. Exactly. The specialized HFT algorithms are all ingesting the exact same SIP data feeds, running highly correlated risk models, and reacting to the exact same microscopic signals in the exact same millisecond. It is a massive information cascade waiting for a single microscopic catalyst.
That is a highly valid concern regarding structural fragility, which is exactly why we must examine how modern operators in both the biological and financial domains are actively attempting to engineer systemic resilience.
Can we engineer it without breaking the system?
How do we manage transfer entropy and introduce vital diversity without sacrificing all the spectacular performance gains of a low-entropy optimized system?
I'm all ears.
In the biological domain, we are no longer passive observers of the evolutionary engine. We are now capable of direct mechanical intervention. I am referring to CRISPR-Cas9, the revolutionary gene editing technology adapted from the natural immune defense systems of bacteria.
We are manually editing the blocks.
CRISPR allows us to physically manipulate biological transfer entropy at the most fundamental level.
You are talking about the targeted artificial injection of entropy into a genome.
Exactly. CRISPR utilizes a synthesized guide RNA sequence to direct a Cas9 nuclease enzyme to a precise location on a DNA strand. The enzyme cuts the DNA, allowing researchers to insert or delete highly specific alleles.
So we can write our own mutations?
We can introduce targeted genetic variation and mathematically observe how that change cascades upward through the organism's phenotype and its overall ecological fitness.
Do we have a real-world example of this scaling?
Look closely at the groundbreaking agricultural work coming out of the Chinese Academy of Sciences. They have been utilizing CRISPR technology to engineer resilience into commercial rice cultivars, specifically Oryza sativa.
Rice is incredibly optimized.
The modern commercial rice crop is a quintessential biological monoculture. It possesses near-zero genetic entropy. It has been relentlessly selected and optimized purely for maximum caloric yield.
But as a result,
it is terribly fragile to novel pathogens and climate shifts.
So they're injecting diversity back into the system.
Yes, but with surgical precision. By using CRISPR, the researchers are selectively cutting and pasting specific disease resistance and stress tolerance genes from wild, uncultivated, high-entropy rice varieties, such as Oryza rufa pagone, directly into the optimized commercial genome.
They are borrowing from the generalists.
They are artificially injecting just enough vital genetic entropy to cure the monoculture's systemic fragility without disrupting the alleles responsible for the high yield. They are actively engineering biological resilience by mathematically tuning the Shannon entropy of the genome.
And here we arrive at the absolute, perfect, regulatory isomorphism.
How so?
What the geneticists at the Chinese Academy of Sciences are doing with CRISPR and the rice genome is precisely, mechanically identical to what modern financial regulators and innovative exchange operators are attempting to do with modern equity markets.
The circuit breakers.
When the Securities and Exchange Commission designs complex circuit breakers like the limit-up, limit-down mechanism, or when an independent exchange like IX implements structural speed bumps, they are acting exactly like agricultural geneticists or conservation biologists.
Managing the cheetahs?
Exactly. They are actively managing the breeding programs and the genetic variants of an endangered, hyper-optimized ecosystem.
They are artificially managing the flow of transfer entropy.
Exactly. Consider the mechanics of the limit-up, limit-down circuit breaker. It is an artificial regulatory mechanism designed specifically to physically halt an information cascade.
By pausing the market.
Right. If the price of a security moves beyond a mathematically defined band within a 5-minute window, trading is paused. It forcefully severs the transfer entropy spike.
It stops the fever.
But the IEX speed bump is the most elegant example of artificial entropy injection. IEX physically routes all incoming orders through 38 miles of coiled fiber optic cable stored in a shoebox-sized enclosure.
Literally forcing the light to travel further.
Yes. This physically forces a 350 microsecond delay on every single order.
It introduces artificial friction.
It introduces artificial diversity in the exact arrival times of the orders. That tiny fraction of a millisecond prevents the HFT monoculture from perfectly synchronizing their latency arbitrage strategies.
It stops the clones from acting in unison.
It prevents them from simultaneously identifying a signal and instantaneously draining all the liquidity from the order book. The speed bump mathematically forces the probability distribution to flatten out just slightly.
Engineering resilience.
The regulators and the exchange operators are attempting to engineer a mandatory minimum level of ecosystem diversity to ensure that transfer entropy cascades cannot destroy the market structure.
That is a brilliant, unifying framing of the mechanics. It really brings us to a total synthesis of the entire life cycle governing these complex adaptive systems.
The 4 phases.
Yes. Whether we are analyzing the 3.8 billion year optimization of cellular DNA or the daily execution of millions of trades per second in New Jersey data centers, we are observing the exact same 4-phase mathematical structure playing out over different temporal scales.
Break down the phases.
Phase 1 is the compression phase. The biological or financial system undergoes rigorous selection. It becomes highly optimized and phenomenally efficient. Biological fitness peaks, bid-ask spreads tighten to a penny. But systemic fragility simultaneously reaches its absolute maximum.
This is the cheetah. This is the modern HFT monoculture.
Exactly. Then, phase 2 is the fracture phase. The novel exogenous shock arrives, a feline coronavirus, a flood basalt eruption, or a poorly coded mutual fund algorithm.
And the system breaks.
The highly specialized, dominant population fundamentally cannot process the new environmental data. Transfer entropy spikes dramatically, the limit order book hollows out, and the system fractures into a mass extinction event.
Which mathematically forces phase 3, the state of maximum disorder.
The Cambrian Explosion.
Exactly. This is the immediate aftermath of the localized extinction. The surviving generalists take over. We see the Cambrian Explosion flooding the oceans with radical new body plans, or the chaotic, highly volatile market recovery driven entirely by diverse, passive limit orders resting deep in the book.
The Shannon entropy of the system reaches its absolute maximum.
And finally, the engine transitions into phase 4, the recompression phase. The period of adaptive radiation concludes, the environment stabilizes, new, highly efficient dominant species, or new, highly optimized HFT algorithms emerge from the chaos.
And the cycle repeats.
They begin to relentlessly outcompete the diverse generalists. Ecosystem entropy steadily falls, the system reoptimizes around the new normal, and the biological or financial cycle inevitably begins again.
The temporal scale, geological epochs versus financial milliseconds, is literally the only independent variable.
It really is.
The temporal scale is the only variable. The underlying mathematical engines are completely identical. And I believe this structural reality forces us to converge on the central tension we established at the very beginning of our analysis.
The tension between efficiency and resilience.
Exactly. I will gladly concede that unlimited, unregulated, high-frequency trading concentration is a dire systemic threat. It drives the market's genetic diversity so incredibly low that flash crashes and liquidity wipeouts become mathematical inevitabilities rather than rare historical anomalies. Extreme, unchecked entropy compression destroys the resilience necessary for a system to survive.
And I will concede, based on the evolutionary record, that eliminating high-frequency trading entirely or artificially forcing the modern market back to the high-entropy, slow-moving floor trading days of 1990 would fundamentally destroy our financial efficiency.
We'd be going backward.
We would be throwing away the biological equivalent of powered flight, complex immune responses, or echolocation. The bid-ask spreads would violently widen, global capital allocation would become sluggish and expensive, and the market would fundamentally fail to process complex information efficiently.
We need the trade-off.
We absolutely need the selection mechanism. We require the friction of the trade-off.
We fundamentally agree on the mathematical isomorphism. Biological evolution and global financial markets both absolutely require the ongoing, violent tension between entropy injection, genetic variation, and diverse order flow, and entropy compression, natural selection, and executed trades.
You can't have one without the other.
Neither pure, chaotic mutation nor pure, ruthless selection produces a functional, enduring system. The optimal state of survival, whether you are utilizing CRISPR to design a resilient global food supply or engineering speed bumps to maintain a stable global equity market, is the active, deliberate maintenance of moderate entropy.
This is the Research Desk officially signing off.